The polynomial expressions can be added or subtracted in order to visualize what happens when two polynomials are combined. We can create a model. Sketch the model. Okay, we're not actually going to use the algebra tiles on this. We're going to do that when we do factoring. We did talk about what algebra tiles look like yesterday. We talked about when we did this in Unit 1, we talked about several ways we could do this. We could say, okay, these are x squareds, and these are x's, and these are constants. And then some of you are really good at looking at it horizontally, and you're like, I can put them together this way. But we also talked about you could do this vertically, where if this is a helpful method for you, and again, I don't really care which method you use as long as it makes sense to you. This is kind of like what we did when we did elimination with systems. So if looking at it vertically helps you versus looking at it horizontally, either way, whichever method is best for you, that's what I want you to do. Because everybody's brain works a little bit differently. So if you can look at it with the color coding, or if you did like circles and squares and underlines or whatever markings you did to say these go together, and you can look at it horizontally to do that, that's fine. If putting it in a chart like this and grouping all the things that match, if that works better for you, then do that. Either way, you're going to get the same answer. What is the answer we're going to get here? 3x squared. And then what's 5x minus 2x? Positive 3x. Make sure you have a sign in between. And what's negative 3 plus 1? Negative 2. So there is our sum. 3x squared plus 3x plus 2. What did we do? How did we know that that was the answer? How did we add these together? What were we looking at specifically? So we collected like terms. And we didn't use algebra tiles there. So what we're going to focus on this part today, polynomials can be added by identifying the like terms and adding the coefficients, right? We're not changing anything when we add and subtract with the exponents. We're just looking at those coefficients. How do we find like terms? They have the same variable and powers, right? So yes, if they just have x's, that's great, or y's, that's great. But if we have like x squared, we need to make sure that we put it with only x squareds. We have two different methods. We have a horizontal method. And again, some of you don't even need to do this. Some of you are like, these two go together, and these two go together, and these two go together. Some of you are really good at looking at it like that. As they get longer, that might be a little bit trickier. Some of you like to take those things and you like to say, okay, I'm going to put my x squareds in the same grouping, and I'm going to put my x's in the same grouping, and I'm going to put my constants in the same grouping. So you can do it that way. Or, like we did a minute ago, you can do the vertical method where you've got, 5x squared, you've got your 4x, and you have your negative 7. And out of these three ways, again, I just want you to do the way that makes the most sense in your brain, because everybody's a little bit different. It doesn't matter which method we use out of all of these, we're still going to get 3x squared plus 7x minus 18, no matter which way that we decide to do this. Okay? So I want you to make sure you pick the way that works best for you. So no matter which way you did this, make sure you do pay attention to your signs. You should have gotten 9x squared plus 3x minus 6. So I do want you to notice right here, I'm going to erase this just a little bit. When I drew my circle, I kind of covered up that minus so it looked like a plus. So just be really cautious when you are doing whatever method is you are, and make sure that your signs match. So subtraction is the same as adding the inverse, or what's another word for inverse? Opposite. For 15 through 7, we can rewrite, or 15 minus 7, we can rewrite it. Now, we don't normally do this plus a negative. But what we do need to make sure we do is that we distribute our negative. So we're probably not going to write it that way, but when we are subtracting polynomials, we'll rewrite as an addition. This is really more of what we do. Adding the opposite, which is just a fancy way of saying we are distributing a -1. Because we're going to put a 1 with that negative sign, okay? So what we would do here, right, we're going to put our 1 in front of our negative, and we're going to distribute this. Now, when you do that, I need you to make sure that you are super, super careful with your signs, because your numbers are not going to change, just your signs. A negative times a positive is a negative, and a negative times a negative is a positive. So we can put the -1 here. We're not going to simplify this one. I just want you to rewrite it. So negative times a negative is a positive. Negative times a positive is a negative, and a negative times a negative is a positive. So on this one, when you do the distributing of that negative, it's really, really important that you rewrite. Don't try to change the signs within, don't do this. Don't be like, oh, this is a plus, and this is a minus, and this is a plus, because you're going to end up confusing yourself. It's really important that you go ahead and you actually just write what the new one is. One of the things, because I do like to do things vertically, is when I change that sign, I just write it underneath so I can see what matches. So negative times a negative is a positive, and negative times a positive is a negative, and then a negative times a negative is a positive. So now everything's nice and neat and orderly, and I can go ahead and I can do my combination of my x's and my constants and my x squareds. I made a mistake on this one, so this should have been a 1, not a 9. So when we look at this one, all right, ready? Here's our negative, so negative times a positive. Ooh, but look what happened. Can I put it there? No, they've written it out of order. Written it out of order, so that is not a good thing. So we need to make sure that we are putting it in the correct spot. So we really need to put it here. Or you just rewrite the whole thing. A negative times a negative is a positive, but that's my constant. And then I have negative 4x. So you can go ahead and negative 2x, negative 12x squared, plus 20, but when you write it, make sure you write it in standard form. So we need that x squared first and ending with our constant. Got a couple different things going on here. We could technically put a 1 here and a 1 here. Does it matter if we distribute a positive 1? No, but make sure, if you are a person that is worried about accidentally distributing the 4x squared, because it is technically in front of the parentheses, even though it's not directly in front of it. If putting the 1 there helps you remember, oh, I'm not doing the 4x squared, I'm doing the 1, then do that. If we distribute a 1, it doesn't change anything. It just makes our parentheses go away. But on this next one, we do need to distribute that negative. And then after that, now we can start collecting like terms. So you could put 1x squared, or you could just put x squared. And then we have a 5x minus an 8x. Oh, I did it again with the circle there. So please be careful so that we don't want that negative 4 to look like a positive 4. So negative 3x and then just our minus 4. I would definitely use my calculator with my fractions. So we have, I mean, technically it's a positive 1, so we're not really changing anything. So 1/5 and 3/5 is 4/5. If they have the same denominator, it makes life really easy. Otherwise, just use your calculator. So plus 2/3 x, and then you've got a -8 and a +9, so a +1. Find the error. Remember, when we do find the error, you should really just solve it yourself. Can you see the error already?
Yes.
This is a positive, but this should be a, they wrote negative, but it should be a positive, and this should be a negative. So it says find the error and correct it. So if we rewrote it, 7x squared plus 8x squared, so that's your 15x squared. But then this should have been a positive and this should have been a negative. So positive 7x minus 9. So signs do make a difference. We have the big area of the outdoor rug. And then we have the shaded area. That's this 12x squared minus 5x plus 1. And then on the inside, I'm going to kind of write it sideways so it'll fit. 8x squared plus 2x minus 4. The question is, write an expression to represent the area of the gray region only, right? That 12x squared, that's the whole rug. So if we want only the gray area, what are we going to have to do? We're going to have to subtract. Now, when you set this up, guys, remember, we're not just saying minus 8x squared. We're saying minus that whole term, okay? Minus the 8x squared plus 2x. I'm going to have to write kind of small here, minus 4. So you have to distribute this negative all the way. So then we have minus 8x squared minus 2x and plus 4. And then you can put it together. So make sure you're distributing all the way through, because if you don't, it's not going to work out.